Good morning or good afternoon, as the case may be. My name is Sosale Mohana. I'm a maths teacher who has taught maths for over 50 years in 3 continents and 3 countries, like India, in Asia, Kenya in Africa, and England in Europe. I've just retired a couple of years ago, and I thought I should use my experience to record and deliver a number of lessons based on the British curriculum for A-level maths, so the students who want to reinforce their learning can use it. I have a master's in maths, of course, way back in 1969. I completed my master's in maths, and then I did my teacher training in 1974. I've been working since 1969 till 2019, clear 50 years. So I hope these lessons are useful to you, and you're welcome to watch them, and then with each lesson, there will always be a document which covers whatever has been done in the lesson, so you could use that perhaps as your own notes, or maybe to go over what has been taught during the lesson. I hope you enjoy the lesson. Hello, welcome back. In the last lesson, we talked of uses of discriminant, and I told you I will go ahead with a bit more of algebra. We are still in basic algebra. See, at A level and beyond, we don't always deal only with quadratics. You'll have a 3rd degree equation. You'll have a 4th degree equation. You'll have a 6th degree equation. And sometimes, if you do further maths, in complex number, we talk of an nth degree equation, where some of the roots are real, some of the roots are imaginary. So, in other words, we can't always stick ourselves only to quadratic equation, because that is GCSE. Now we are all clever people, we're gone beyond. So now at A level, see, for a quadratic equation, there's a standard formula. Minus b plus minus root b squared minus 4ac whole over 2a. Even in your dream, you people know it, and you can repeat it and do it. But what if it's a cubic? There's no standard method of solving a cubic. Then sometimes you come across a 4th degree equation. Some of the 4th degree equations can be written as quadratics. Some of them can't be. So it becomes harder and harder as the power goes up. Of course, there's a whole branch of algebra dealing with roots of an equation, symmetric roots and symmetric equations, and the coefficient from one end is the same as the other end. Oh my God. There are so many things, but fortunately we don't have to do all that. But we are teaching you basic algebra. So what we do for a cubic, I think is more applicable to a cubic at your level, or at most a 4th degree equation, is we do trial and error to find one root, and later on we get another equation, do trial and error to find one more root if we can, and then we reduce it to a quadratic, and which then you're back to your familiar path of using the quadratic equation. So in other words, we are looking for roots. The word roots leads to factors. But then that means you're able to factorize. As you saw in quadratic equations, there are certain equations which can never be factorized. So then we also know what happens when you divide. So in other words, since you can't factorize it, whatever you divide by, you're going to have a remainder. So we're looking at the remainder theorem and the factor theorem. To understand this, you need to go back to your GCSE to remember how you did long division. Let me tell, so in other words, we are still the same topic too. I think it's becoming boring, isn't it? Basic algebra. And then in that, we are now looking at factor and remainder theorem. In fact, more remainder theorem we are interested in than factor. More factor theorem than remainder theorem, but they go hand in hand. So actually, there is no separate factor theorem in a way. Factor theorem is a deduction of the remainder theorem. To understand this, Suppose let's say I've got an f of x, an equation which is x power 4 minus 7x cubed plus 6x squared minus x minus 2. Ooh! Sir, you suddenly jumped into a horrible equation when we were just dealing with 2x squared and 3x squared. Unfortunately, we have to grow up now from GCSE year 11 to year 12. You're climbing up. In school, don't you have freedom? More freedom. You don't have to sit at one place. You go and sit in a common room. You go and sit in the library. When you have that freedom, you also must a certain responsibility. So you have to go up. Good. Now I am dividing. I want to find the remainder when divided by x plus 1. I'm taking a very simple example. So I'm going to divide that by x plus 1. Let's see what happens. So in other words, I'm going to a GCSE. So we write that. I don't know how your teachers might have taught you in a different way, but I will show you so many different ways of doing it. You can figure out which way you want the long division, x plus 1. This is similar to what you do in arithmetic. Suppose I had 9, 7, 4, 6 and you're dividing by 6. What would you do? You don't multiply. You look at the first number is 9. The first number is 6 here. So 6 ones are 6. And then 9 minus 6 is 3. Then you bring the next one down. Correct? In fact, you can bring all the 4 of them down. In other words, you compare the highest power of the divisor with the highest power of the dividend. So therefore, x power 4 and x. So x goes into x power 4, x cubed times. Here what did I do? I multiplied 1 by 6 and wrote there. So multiply x cubed by that and write below. X cubed times x, x power 4 plus x cubed times 1, x cubed. Let's go back here. What did you do in GCSE in primary school? Subtracted. So here also subtract. When you subtract, that goes minus 7 minus 1 is minus 8x cubed, which is like your 3. You bring the 7 down, so bring the 6x squared down, bring the 4 down, I'll bring the x down, bring the 6 down, I'll bring the 2 down. It's easier that way instead of going so that you don't forget. But be careful, copy correctly. Now the high 37. So here I'm looking at two things. 3 doesn't go, so 37, you say 6 6 36. Yeah? So you can subtract by 1. Again you subtract, right? Here, in algebra, you just only look at the first term. Minus 8x cubed and x. So I require a minus 8x squared. So minus 8x squared times x, minus 8x cubed, minus 8x squared times 1, minus 8x squared. Take away. So these two cancel. Minus of minus is plus. 6 plus 8 is 14x squared minus x minus 2. Here, let's go back. 1, 4, 6. What do you do next? This is 14. That is 6. So 6 2s are 12. You subtract. This is 14x squared. That is x. So multiply by 14x. I get 14x squared plus 14x. Good. So 14 minus 12 is 2, 26. Here, take away. I should have put a bracket. This cancel. Minus x minus 14x is minus 15x minus 2. Remember, that's an x, that's an x. So I can still divide by 15. So here, 6 4s are 24. The remainder is 2. So x times minus 15 is minus 15x. Minus 15 times 1 is minus 15. Again, take away. They cancel. 15 minus 2 is 13. There is no x. I can't divide by further. In other words, this is x. How you remember is that x power 0, that is x power 1. You can't divide. 2 is smaller than 6. you can't divide. The logic there is you can divide as long as the powers are the same or the power is higher. If the power is lower, you cannot divide. So therefore, that was only an example to show you there is not much difference between your. Remember how you did in arithmetic, the same method applies in algebra. So therefore, you can say, so I can write f of x as x cube minus 8x squared plus 14x minus 15 times x plus 1 plus remainder is 13. How did I do that? Let's go back. Suppose you're doing 37 by 5. 5 sevens are 35 and 2 fifths, right? But basically you're doing is 7 times 5 plus 2 is 37. Divisor times quotient plus remainder is the dividend. So this was the quotient, that was the divisor, that was the remainder. So the original function or original polynomial or original expression is quotient multiplied by divisor plus remainder. So therefore, you're asked to find the remainder. So you write the answer, remainder equals 13. Of course, you don't have to write this, but I will need it when we do partial fractions later. At the moment, I don't need it. Okay? How to use it also, I will show you later. Not exactly the same way, I'll divide by x plus 1. Good. So therefore, I got the remainder 13. But let's see something interesting. And unfortunately, in the exam, they didn't, suppose they gave only 2 marks. You think all this work is worth 2 marks only? That's strange. Sometimes they say find, or they will say this, using remainder theorem. So many a time what happens is students have forgotten remainder theorem. I've come across in my own tests and exams in the school. They have forgotten because remainder theorem was done somewhere in the first term of year 12. Now in the mock exam this question has come. That particular boy or girl hasn't bothered revising what happened in year 12. Unfortunately, something says, I don't know, but something, I don't know. I could be wrong. So safer, let me do long division. They did the long division. They got the answer. I gave them a 0. Because I said, I want you to use remainder theorem. If I didn't say this, you did this, yeah, you'll get your 2 marks. But I said, use remainder theorem. I think in 90% of questions in the exam, they always say, using remainder theorem. So, you are expected to use, what is this remainder theorem? Oh my God. Remember how much of painstaking work we went through. Let's look at this expression. Very interesting expression. Let me write this. I don't even need the coefficient, so I don't want to do long division. Fine. So what I'll do is, I will say, again, this you don't have to write in the exam. F of x equal to something, I don't know, times x plus 1 plus the remainder. Correct? Because I'm dividing by x plus 1, so I'm going to get a quotient and I'm going to remainder. What happens when x is minus 1? So f of minus 1 equals, when you put x as minus 1, what happens to that? That becomes 0. 0 times plus remainder. 0 times anything is 0. So remainder equals f of minus 1. In GCSE you learned f of minus 1 means wherever you have x, you write minus 1. So remember the remainder there, that oh my God, divided by x plus 1, and I got the answer after division as 13. Let's go back there. X plus 1 equals 0, x equal to minus 1, f of minus 1 equal to minus 1 power 4 minus 7 times minus 1 cube plus 6 times minus 1 squared minus 1 minus 2. So 1 plus 7 plus 6 plus 1 minus 2, 30. That's why it is 2 marks. 1 mark for trying to find f of minus 1, 1 mark for the answer. That is all remainder theorem is. So, in a nutshell, remainder theorem is, so I just took an example to show you what remainder theorem is. So, in general, we can say if f of x is divided by x plus a, then the remainder is f of minus a. That is, put x plus a equal to 0, x equal to minus a, substitute minus a into, substitute x equal to minus a in f of x. That's the shortest way to find remainder doing long division. But then, let's take another example. I'm not sure, I might have to work this out. Give me a minute. I'll just work out here. For example, you are given f of x equal to x cube minus 4x squared minus 29x minus 24. Find remainder when f of x is divided by x minus 8. And hence solve x cube minus 4x squared minus 29x minus 24 equals 0. That could be a question. I just made up the question, obviously. I know the answer, and some of you who are clever will already figure out the answer. So, remember, when you want to divide by x plus a, equate that to 0, find the value of x, put it into the equation. So that's what I will do. Here, I got x equal to 8, x minus 8 equal to 0, x equal to 8. So what is f of x? Is 8 cube minus 4 times 8 squared minus 29 times 8 minus 24. 8 cube is 512. Yeah? 64 times 8, yeah. 8 squared is 64, 256. 8 nines are 72. 7, 16 plus 7, 232 minus 24. 4 plus 2, 6 plus 6, 12, 1. 2 plus 1, 3 plus 6 plus 11, 1, 5. 512 minus 512 is 0. The remainder is 0. If the remainder is 0, it's a factor. That means, remember, I wrote you previously. So f of x equal to x minus 8 times something plus 0. So that 0 is of no use. So I can get x minus 8 as a factor. Unfortunately, now you can't escape long division. So I'll take this, I divide by x minus 8. So what will happen? X cube minus 4x squared minus 29x minus 24. I'm dividing by x minus 8. So multiply by x squared, I get x cube minus 8x squared. Take away, I get minus 4 plus 8, 4x squared minus 29x minus 24. So multiply by 4x. I get 4x squared minus 32x. Take away, they go. 29 and plus 32 is 3x minus 24 plus 3. 3x minus 24 is 0. See, the remainder should be 0, otherwise you've gone wrong in division. Or I've gone wrong in my calculation. Since my built-in calculator is correct, you will have gone wrong in your division if you don't get a 0. So therefore, I can say f of x equal to x minus 8 times x squared plus 4x plus 3. And you're asked to solve it. So equate it to 0, I get x plus 3 and x plus 1. So your roots are x equal to 8, minus 3 and minus 1. So in other words, indirectly I have taken you through remainder factor theorem. Factor theorem is nothing but remainder theorem. When the remainder becomes 0, it becomes a big thing. Back factor theorem. There's no factor theorem, just a remainder theorem. So if the remainder is 0, then that's a factor. If it is a factor, you can factorize f of x. Once you factorize f of x, you can find the roots. Right? So let's put that also in perspective. As I said, the handout will be there for you. I don't think there's any handout necessary. I'll just give you the definition. That's all in the handout. So if f of a equal to 0, then x equal to a is a root of f of x equal to 0, which means x minus a is a factor. That is factor theorem. So I've given you a brief introduction to factor theorem and remainder theorem. I will take a couple of examples next time. I don't think it is necessary. You will see the examples, and I'll let me do a couple of more examples in the handout so that you understand it. From here, I will now move on to basic coordinate geometry. From then on to curve sketching. Thank you very much. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.